Welcome to sitza.com. Find the product formed when each of the following alkenes over here, it reacts with the bromine in aqueous solution in the water. So here we have a 2-methyl 1-butene. What is the product when bromine in the water reacts with it? 2-methyl 1-butene is like this. It is CH3, CH2, CH3 here, and we have a double bond and a CH2. In our last video I have shown you the mechanism, how the bromine or any halogen molecule in the water reacts. It is actually the addition reaction, electrophilic addition reaction. One carbon, double bonded carbon here gets a bromine atom and the other carbon gets a hydroxyl group. The mechanism I have shown. We know it's the bromine, electrophile, which actually attacks on it, on the double bonded carbon, and forms a bromoamine. So what you get? You get a CH3 here, CH2, C, and a single bond CH2 and a bromoamine. It forms a cyclic, intermediate. We have a methyl group also over here. And then it is a water molecule, H2O molecule, that's going to attack on this particular carbon, and this carbon and the bromine bond breaks and it shifts towards the bromine here. And what you get a molecule like this, CH3, CH2, C, and the oxygen with the positive charge here, methyl group, single bond CH2. It shifts, this electron pair shifts to bromine, so you get a bromine over here. And then what happens? Hydrogen is lost as H positive. It is released as H positive, so you get the hydroxyl group there. So you see the product will be CH3, CH2, COH here, hydroxyl group here, and a CH3 here, and the CH2Br. So look at the addition reaction. So what's the net reaction over here? The net reaction is double bond breaks, one carbon gets a bromine, the other carbon gets a hydroxyl. Bromine, Br positive, which is electrophile, since this is an electrophilic addition reaction. So in this reaction, what happens? The electrophile, it is added to the carbon with more number of hydrogen atoms, right? See, here is the electrophile Br positive that is generated from the bromine molecule. The mechanism of it, I have shown in a previous video, so you can go there. So what we find here, it is the overall addition of a bromine and the hydroxyl group across the double bond, right? Bromine added to the carbon with more number of hydrogens, and hydroxyl is added to the double bonded carbon with more substitution around. So let's take one more example over here. We have a 2-methyl 2-butene. So 2-methyl 2-butene, you can say it will be like this: CH3 carbon, hydrogen, a double bond, CH3 and a CH3. Now this is a 2-methyl 2-butene, and again if you react with the bromine, what will happen? It is the electrophile that will attack on the double bonded carbon, so the double bond breaks and it forms a cyclic bromoamine, right? The cyclic bromoamine is formed in the first step, and then it is the water molecule that will attack on this particular carbon, right, on the cyclic bromoamine. So when you react with the water, what happens here? The hydroxyl group H2O will be added to the carbon with more substitution. So if you compare here, this carbon has a more substitution, so you will get a hydroxyl on this one and the bromine will be here. It means that the this water, which is the nucleophile, will attack over here, and this electron pair, it will be kicked to the bromine. So what you get? You get a CH3 here, carbon with a bromine and a hydrogen atom, single bond carbon, CH3, CH3, and an oxygen there with 2 hydrogen atoms. Is the water molecule, so it will get a one formal positive charge, and then hydrogen will be released here as a H positive, correct? So it will be loss of H positive here in this. So what you get, final product will be the CH3, CH, Br, and the COH here, and this is the CH3, and this is the CH3. Overall, it is the addition of halogen atom and a hydroxyl group. Halogen is added to the double bonded carbon with more hydrogens. Hydroxyl group is added to the carbon with more substitutions around, right? So let's take one more example here. Now we have a 3-methyl 1-butene. 3-methyl 1-butene is like this. It is the CH3, CH, CH3 here, and then you have a CH double bonded CH2. Again, we react with the bromine molecule. So what you will get, it forms the cyclic bromoamine here. So you get CH3, CH, and a CH3 over here, and then a CH single bond CH2, and a cyclic intermediate will be formed like this. And then when the water molecule attacks on it, water is a nucleophile, it's going to attack on this carbon, right, with the more substitution around. So it will push the electrons towards the bromine. So final product will be CH3, CH, CH3. It is the carbon, hydrogen, and a water added to this, and a CH2Br. And this oxygen with the positive charge, then it will release the hydrogen from here as H positive. So what do you get? Now you get a CH3, CH, CH3 here, CH hydroxyl group, and a CH2Br. So again you see the addition of the bromine and the hydroxyl group. Bromine is added to the carbon with more hydrogen atoms. Hydroxyl group is added to the carbon with more substitution, or you can say with a less number of hydrogen atoms. So overall it is the addition of a bromine atom and the hydroxyl group. And this again, this is an electrophilic addition reaction because it is, it is the electrophile that attacks on a double bonded carbon. Now we have another example, 1-methyl cyclopentene. A 1-methyl cyclopentene, we can say it's like this. The structure will be for the cyclopentene. So let's suppose we have a double bond here and we have a methyl group here. Again, if I react with the bromine, so the intermediate will be the cyclic bromoamine. The intermediate compound will be, it will look like this. We have a bromine here and a bromine here, and then we have a methyl group here. This is with the positive charge. And then in the next step, it is the water molecule that is going to attack on this particular carbon. So water molecule H2, a nucleophile, is going to attack on here. It will push the electrons over here, and then what you get an intermediate like this with the methyl group here, and oxygen with the 2 hydrogen atoms over here with the one formal positive charge, and you get a bromine here. And then it will be the loss of a hydrogen as H positive. So loss of H positive will be here. So what do you get? You get a compound like this, OH here, methyl group here, and a CH and a bromine here. So again, look at the net reaction is bromine is added to this particular carbon, and hydroxyl group is added to this carbon over here. Double bond breaks, and you add the two species, bromine and the hydroxyl group. Hope you got it. Thanks for watching the video. Bye for now.